Right, question 6. A rough plane is inclined at an angle alpha to the horizontal. Lovely. Alpha to the horizontal. Where sine alpha is 3/5. Remember what I was telling you now, how to use this information. Okay, it gives you this so you don't have to work with decimalized angles on your calculator. If sine alpha is 3/5, 3 is the opposite, 5 is the hypotenuse, which means the adjacent must be 4. So if sine alpha is 3/5, cos alpha would be a over h 4/5. So what? A body of mass 80 kilograms lies on the plane. So it's going to have a weight of 80 g. The coefficient of friction between the body and the plane is mu. Find the normal reaction of the plane on the body. The body is on the point of slipping down the plane. Right. So my normal reaction is there. It wants to slide down the plane, so my frictional force is going to act up the plane. Calculate the magnitude of the force along the line of greatest slope that will move the body up the plane with an acceleration of 0.7. So that's going to change for that second bit because it's suddenly going to move up the plane. So first of all, let's write down our equations. So I am going to initially have what am I going to do? Up the plane. So I'm going to have plus x plus y. So on the point of slipping, so at the moment it's in equilibrium. So the sum of the x forces, I'm going to have F, and then the 80g is going to be pulling in the opposite direction, so that will be minus 80g, and this is on the incline, so that angle is alpha, and the horizontal, the x component, is opposite, so that's going to be 80g sine alpha, and that's going to equal 0 because it's not moving. In the vertical, I've got r minus 80g adjacent cos alpha equals 0. So the normal reaction, r equals 80g, and cos is 4/5. So I'm going to do 80 times 9.8 times 0.8, which is what 4/5 is. So 627.2 newtons. I've used G, so to two significant figures, that would be 630 newtons to sig figs. Part A. Find the value of mu. Well, mu F equals mu R. So mu will be F over R, which will be F will be 80g sine alpha, and R is 80g cos alpha. The 80g's cancel, and sine over cos is tan alpha, and tan alpha is opposite over adjacent, which is 3/4 or 0.75. So mu is 0.75. Part C. Calculate the magnitude of the force acting along a line of greatest slope that will move the body up the plane with an acceleration of 0.7 meters per second. So slightly change the setup. What we've got now is we've got a frictional force that's pulling down, and we've got a pulling force that's taking it up. It's accelerating upwards with an acceleration of 0.7. So I'm going to keep my plus x and plus y in that direction. So this time the sum of the x forces is going to be equal to the mass times acceleration. So sum fx will be p minus 80g sine alpha minus the frictional force equals the mass, which is 80, times the acceleration, which is 0.7. My y forces will be r minus 80g cos alpha equals 0. The only ones acting perpendicular to the plane is the normal reaction and the perpendicular component of the weight. And then of course we know that F equals mu r, where mu is 0.75. Okay, so if I call that 1, 2, 3. I need to work out what P is, so I have to end up in equation 1. And in order to do that, I need to know what F is. I get F from here, and I know that R is that. So from 3, F equals 0.75 times R, which is 80g, times cos alpha, which is 0.8. Cos alpha is 4/5. So F is going to be 0.75 times 80 times 9.8 times 0.8. So that's 470.4. I don't round because I want to keep that complete for now. So then in equation 1, P will be 80 times 0.7, which is 56, plus 80g sine alpha, and sine alpha is 3/5, which is 0.6, plus F, which is 470.4. So I got my fourth end, so I've lost that. So I'm going to do 80 times 9.8 times 0.6 equals 470.4. Then I got another 470.4 and a 56. So it's 996.8 newtons, which to two significant figures is 1,000 newtons. Excuse me. So that's question 6.